The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on! The skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm your host, Desiree Shell. This week we're going to spend the hour talking about space. Now, this has obviously been a big year for space stories, but with every Martian rover article, you heard comments that all sound a bit like, should we really be spending all that money on space when it could be used to solve problems here on Earth? So, of course, we here at Skeptically Speaking have assembled a fantastic panel of space enthusiasts who will do their best to convince you that space is indeed worth it. We have Dr. Cynthia Phillips, a planetary geologist at the SETI Institute in Mountain View, California. She uses images taken by robotic spacecraft to study the surfaces of planets and satellites in our solar system. She's also the author of over a dozen books, including Space Exploration for Dummies. Welcome, Cynthia.
Thank you.
Next, we have John Matson, an associate editor at Scientific American magazine. He primarily covers space and physics, and much of his writing has focused on the search for extrasolar planets and the exploration of the solar system. And he has an MA in journalism from the New York University and a BA in pure mathematics from Sonoma College. Thanks for being here, John.
Thanks for having me.
And we also have another John, which is going to make things very confusing. John Zeller, undergraduate studying computer science at Oregon State University in Corvallis, Oregon. He's the founder of Penny for NASA and the team software lead of the OSU Robotics Club Mars rover team. John's always had an interest in science and space, and he's aiming to work in STEM fields pertaining to space exploration and possibly the many aspects of the internet. Hello again, John. Nice to have you back.
Thank you for having me.
And Dr. Nicole Gugliucci is a postdoctoral fellow with CosmoQuest at the Southern Illinois University in Edwardsville. She's the author of the blog One Astronomer's Noise, and she's also a writer for Discovery News. She has a PhD in radio astronomy from the University of Virginia, where she co-founded an elementary school astronomy program called Dark Skies, Bright Kids, which we've talked about on the program before. Hello, Nicole.
Hi, Desiree.
Now, this is obviously a big panel chock full of expertise, and maybe before we talk about why you guys are so passionate about space, I want to make sure that we know a little bit about what you do. So, Cynthia, let's start with you. What does a planetary geologist do?
Well, it's like being a geologist, except that the surfaces that I study are the surfaces of other planets and satellites in our solar system. So basically, I'm interested in using the same techniques that geologists use here on the Earth, but I apply them to other worlds. And one of the really cool things about doing planetary geology, or comparative planetology is another term for what I do, is that a lot of the geological processes that take place on our Earth actually also take place out in the solar system. And that may seem like an obvious thing to think, but for a long time, we thought that the other planets were totally exotic worlds that were completely unlike the Earth. And in some ways they are, and there certainly are processes that go on other worlds that are quite different from what we have here on Earth. But one of the things that I've found the most striking is that, in general, a lot of the same techniques that we use here can also be applied elsewhere. And I'm always surprised when we see the surface of another planet or satellite for the first time. I'm always surprised at often how Earth-like it looks. And I find that really fascinating.
And how does planetary geology fit into the mission of SETI?
Well, there's sort of two different aspects of the SETI Institute. There's the search for extraterrestrial intelligence, which is sort of the more SETI proper side of things. And so we have a Center for SETI Research. And they're the ones who do the whole radio telescope, listening for intelligent signals from technological civilizations, kind of like Jodie Foster's character in the movie Contact. So they're looking for intelligent life. But we also have the Carl Sagan Center for the Study of Life in the Universe. And if the SETI people are looking for intelligent life, we're looking for stupid life. We're happy with any kind of life, microbes, anything, just little tiny things. It doesn't have to be intelligent enough to build a radio transmitter and send signals back to us.
Right.
So that's what I'm doing basically is I'm interested in places in the solar system that could be habitable, that could be environments for life. And maybe that life is very much unlike life as we know it here on Earth, but there are other places in our solar system, such as Mars and some of the moons of the outer solar system, like Europa and Enceladus and Titan, that perhaps could be inhabitable.
All right, let's go from planets in our cosmic backyard to planets that are a little further out, let's say. John Matson, you've written a lot about the search for exoplanets.
Yeah. That's been obviously one of the big stories in the past few years in this field of astronomy and space science in general. Is really this is just a branch of science that's taking off in such a big way. Whether it's the discoveries that people are making on the ground with increasingly advanced instruments like this recent planet that was found orbiting Alpha Centauri B, or whether it's the Kepler mission, which NASA launched, I guess, 3 years ago now, that's discovering exoplanets just in droves and bundles, and every once in a while someone will say, hey, we've got 50 new exoplanets to announce or something crazy like that. So it's just been an incredibly exciting field to cover and to watch sort of mature and blossom in really just a very short number of years. And now we probably should clarify for people, being able to detect exoplanets is sort of a relatively recent thing, right? Yeah, it's very recent. Depending on your definition of what a planet is, which, as Pluto taught us in 2006, is a very heated subject. I know. Let's maybe not get into that. But in any case, it's you could say 1992, the first exoplanet was discovered. So that, the first planet orbiting, in a planetary system that isn't our own. Or most people say 1995, because that was the first planet that was found orbiting a normal star, something that you could sort of say, hey, that looks like our sun. So something that's a little more analogous to what we have here. So, that's either way you slice it, it's 20 years or thereabouts. In which time we've gone from, again, if Pluto was a planet in the 1990s, so we had 9 planets that we knew of in the entire universe, and now we have 700 or something like that. I mean, that's just an incredible explosion in terms of what we know. We've got kind of an observation theme going here. So, Nicole, you're up. And like I said in your intro, you are a postdoctoral fellow at CosmoQuest. So 2 questions. First of all, what's CosmoQuest and what do you do there?
So, CosmoQuest is a citizen science and education astronomy portal. It's a website you can come to and actually help scientists do their science. So, Cynthia was talking about planetary geology earlier, and we have data coming from NASA satellites such as the Dawn mission to the asteroid Vesta, and from the Lunar Reconnaissance Orbiter orbiting the moon, and we're getting all this data, so much data, that we don't have enough people, scientists, to look through it and actually identify surface features. And so you can come to the website, log in, and actually help us identify surface features and contribute to the cutting-edge science that's being done in these worlds. And so I help wrangle the data, and also I'm the informal education lead, so doing a lot of the social media outreach and outreach to schools. We also have a lesson plan that we just put out called Terra Luna for teachers to be able to actually use the citizen science in the classroom.
And maybe just a bit of background.
Yeah.
What does one use radio astronomy for?
So I used radio astronomy when I was a grad student to, we were building a low-frequency radio telescope in South Africa to search for hydrogen from the very, very early universe. And that tells us about what the first stars and galaxies were like, because we can't actually see those first stars and galaxies. We don't have powerful enough optical and infrared telescopes yet to see that. And so we're looking for that hydrogen gas to give us these clues. I've also worked with some of the big interferometers looking at supermassive black holes and centers of galaxies and the jets of matter that spew forth from them. A lot of different things in the universe that you can't see in visible light that you can see in things like radio waves or X-rays.
Okay, from observation to exploration. I love my segues. John Zeller, tell us about Penny for NASA.
Awesome, yeah. I founded Penny for NASA back in March and officially created a nonprofit corporation in the state of Oregon in May. Penny for NASA was made to advocate for the increase in NASA's funding. As most of us, all of us should know, and many of your listeners may know, NASA has not had an increasing budget. They've had quite the opposite, in fact, and they've had a huge cut to their planetary science budget. This is really not something that we should have in a nation that was the first to put a man on the moon. We need to be investing in science and education and space travel, and that's something that feeds towards the inspiration of new students that go into these fields every day. So Penny for NASA was made to advocate for the increasing of NASA's budget. Right now it's 0.5% of the entire budget, which said another way is half a penny on the dollar. So Penny for NASA stands for increasing that one-fold, which would be 1% of the entire budget. And that may seem like a really large increase, but it is only 1% of the budget. That doesn't even, if you cut up a dollar bill, it wouldn't even get you all the way into the ink, as Neil deGrasse Tyson says. So that's one thing that we advocate for, and that leaves NASA's budget right now at $17.7 billion. That would increase it to almost $38 billion, which would be very, very substantial. You look at the amazing things that NASA has been able to do with its budget in its 50 years, and they're amazing things. If we were to double that budget, imagine what else could happen. And yes, there are a lot of different things that NASA needs to fix internally. And we're obviously for a lot of that stuff, but we focus on the funding.
And we will get to that. You're listening to Skeptically Speaking. We are today trying to encourage you to care about space with John Matson of Scientific American, Nicole Gugliucci, postdoctoral fellow at CosmoQuest, John Zeller, founder of pennyfornasa.org, and Cynthia Phillips, planetary geologist with the SETI Institute. Now, I do want to give each of you the chance to make the case that the part of space you focus on is a worthy endeavor, but let's start with direct exploration. And Zeller, you already started on this, which is why I cut you off. So I'm going to start with John, but the rest of you feel free to jump in anytime if you have something to add. Because, John, you brought up all the amazing things that NASA has done now. You know, they've landed a dozen people on the moon. They've orbited 2 space stations, dropped a handful of robots on Mars, unmanned craft. It's brilliant, but I just want to ask you, what good has that done here on Earth?
It's done a lot of good, you know. And after starting this organization, I've had a lot of people come forward, as I'm sure you've heard as well, that ask the same question you posed at the beginning of the show. Why should we be investing money up there when we should be investing money down here? And the truth of the matter is, it's not as cut and dry. When you invest money up there, it is investing money down here. Approximately, and this may be a slightly fudged figure, but from memory, approximately $1 of every dollar that NASA invests, $8 comes back into the economy. That obviously varies over time, but that's a huge return on investment, which I think would definitely challenge most other federal agencies, with NASA being the front runner in those. And aside from just straight economic benefit, most of that money comes back to American companies anyway. It's not just going to fund overpaid scientists or what people think.
There's so many people laughing right now.
No, you know what I mean? Like, I think it's a ridiculous thing to assume that NASA is just hoarding this money and not doing anything useful for anyone. That's quite the contrary. Quite the contrary. Charles Bolden recently was quoted saying 85% of the NASA budget comes back to American manufacturers and their partners. I think that's a perfect explanation of why we should be investing in NASA, besides all of the amazing science and engineering and inspiration that NASA does. From a strictly economic standpoint, all of the reasons to fund it are there.
Well, let's talk about those technological advances. You know, I think the most obvious one has to be satellites.
Yes, absolutely. We get a lot of benefits from satellites. We have GPS is probably one of the things that most people can tangibly feel a benefit from satellites. And if you have a GPS, chances are you don't travel anywhere without it anymore, which is
painful.
Painful, but it's really, really a beautiful technology to be able to do that kind of thing. It's been able to help with disaster recovery. It's been able to help people not just get from restaurant to restaurant, but be able to interconnect in a much quicker and interlaced way. Satellite communications have helped that a lot. And
actually,
obviously not just satellites.
Since we're talking about satellites, and you also mentioned disasters, so weather satellites.
Yes, definitely. Without the weather satellites, NASA created the technology of satellites. Without NASA, we would not have satellites. Therefore, we would not have been able to predict the path of Hurricane Sandy or Hurricane Katrina or any of the other hundreds of hurricanes that have happened over the years. And the technology continues to get better and better and better. Without that, we wouldn't have had evacuation orders in place during this most recent disaster or disasters previously. And the death tolls could have been a lot higher, as well as the economic damage from property.
What do you guys got? What are we missing?
You can throw in so many different technologies that have gotten their start through NASA or through various other space engineering, aerospace engineering companies. Everything from micro robotics that are being used both in space station applications, as well as they have the potential for being used in operating rooms here on Earth, remote telemedicine. For example, the same kind of techniques that could be used on a space station could also be used in a remote battlefield situation to operate on patients virtually or robotically, basically. There's much more mundane spin-offs, things that are far beyond Tang, which is the kind of the joke, the joke. It's a spin-off food, but just ways of preserving, dehydrating food. Those were all invented for NASA. And what something like NASA does is it gives an inspiration, it gives a direction for basic research. And a lot of that research goes in directions that were totally unexpected, and turns into things that we wouldn't have predicted before. And that's really what basic research does. And so rather than NASA publishes these huge, big publications of technological spin-offs every year. And there's a huge number of detailed engineering and technological innovations. But a more important way, I think, to think about it is that it gives kind of a foundation or a reason for basic scientific and engineering research that, yes, supports the space program, but often goes in other unexpected and fascinating directions as well.
Anyone want to follow up on that?
Well, sure. So one thing that I would add, and this is a relatively recent development, but it hasn't gone as smoothly as maybe everyone would hope, but NASA's presence and NASA's funding has helped to spur this whole new industry of private spaceflight, and not so much in the Richard Branson, space tourism vein, right, where anyone with whatever $200,000 or however much it is can fly up to the edge of space and be weightless and see the curvature of the Earth, which all sounds great, but on a journalist salary, I'm probably not going to do it. But the companies like SpaceX and like Blue Origin and Armadillo Aerospace and all these fledgling companies that are very promising. It's hard to say where they're all going to end up in 5 or 10 years, but you have to think that some of them are here for the long haul. And that's all, it's probably not just originating from NASA putting out this call to the private industry to say, hey, we need some help getting astronauts to orbit and getting cargo to orbit and getting cargo to the International Space Station. But it's certainly helped accelerate that, I think. And that's very exciting. That's sort of a fundamental change that's happened just in the past couple of years, that could, help to maybe make access to space more regular, more affordable, which is this goal that people have talked about for a long time and has never really been realized. But maybe we're making some headway on that.
And we'll be right back to talk about why exactly you should care about space on Skeptically Speaking after this.
Skeptically Speaking wants you to question everything. To be a part of the discussion, call and record your question on our listener question line at Speak 73101. That's 773-257-3101. Long-distance charges may apply. Sunday nights at 6 Mountain Time, join our Ustream chat room to listen and ask questions as we record interviews live. Just click the Listen Online button at skepticallyspeaking.com. You can also email your questions and comments to live@skepticallyspeaking.com, or if you're on Twitter, tweet us at Skeptical Radio. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and today we're talking about space with Nicole Gugliucci, postdoctoral fellow at CosmoQuest, John Zeller, founder of pennyfornasa.org, Cynthia Phillips, planetary geologist with the SETI Institute, and John Matson of Scientific American. So maybe let's move from exploration back to observation. John, you write quite a bit about the search for planets around other stars. I'm sure that orbiting satellites are a big part of that work, correct?
The Hubble Space Telescope has done some of this work. The Spitzer Space Telescope has done some of this work. There was a French satellite in the past couple of years called Corot that discovered a lot of planets. But the Kepler satellite, which is in orbit actually around the sun rather than around Earth, is just totally cleaning up. I mean, it's just completely changing I don't know. Well, I guess it is changing the way that people think about extrasolar planets, but it's certainly changing the base of knowledge that people have. Just hundreds and hundreds of discoveries that are starting to come in. I think they have about 100 confirmed planets now, something like 2,000 plus unconfirmed candidates that are, they're likely mostly planets. A few of them will be false positives, but just an incredible bounty of observations that are being done relatively cheaply. I mean, the Kepler mission, I think, cost $600 million to start, which is a lot of money, if any way you slice it. But for the amount of interest that it's generated in science, in space, in technology, you name it. I mean, every time I'm talking to people that I know and tell them what I do, they ask me about extrasolar planets or the latest discovery, or, the Kepler mission has become a household name. And I think that's a really astonishing thing that has been done by NASA with, I would say, relatively little money for what it's accomplished.
So what are we learning exactly from exoplanets that we can apply to our own planet?
Well, what we are learning about exoplanets that we can apply to our own planet is just sort of, we're just sort of starting to tune in the station. At least that would be my argument. Cynthia may disagree, but the Kepler mission was specifically designed to be sensitive to Earth-sized planets in the habitable zone of their stars. So, in other words, analogs of our own planet. A planet that weighs the same as the Earth and it orbits on a 1-year orbital period. And we don't have any of those planets yet, simply because we haven't had the technology to detect them. Earth is a relatively small planet. It's compared to most of the extrasolar planets we know about, it's pretty far away from its star, which makes it hard to detect. And so, in the next couple of years, we should start to see these planets, unless they're much, much rarer than people thought, which would, in and of itself, be a really interesting discovery. I mean, if planets like Earth are really rare, and we happen to live on Earth, and it happens to be a really nice, habitable place, that puts a lot of things in context in terms of the importance and the rarity of this place that we have, and maybe the rarity of intelligent life in the universe, if indeed life requires a place sort of like this to spring up and flourish. And of course, if you find a lot of planets, that points in the other direction. So we're just on the cusp of starting to really get the things that we can apply to those big questions. But you can almost taste them. It's a really exciting time.
We have a question from the chat from Insider.
Why don't scientists who discover exoplanets for the first time get to name them? Biologists can name newly discovered organisms, and astronomers can name asteroids. Why not new planets?
Wow, that's a really good question.
We're getting ripped off, people.
I know. Cynthia, do you know that? I don't know the answer to that. I mean,
my guess would be that the classification system is defined by the International Astronomical Union. They're basically an international body that deals with naming of features on planets, features on satellites, asteroids, etc. My guess would be that since the stars already have names, they already all have official names, that the that when new planets are found, they're named as kind of like a subsidiary of a particular star. And I think they use it in order of discovery. So it'll have, the name of the star. And some of these names are, like HD 114576 or something like that. Like they're pretty boring sounding names in various catalogs. And then the planets will have letters like, A, B, and C in the order that these planets are discovered, around the star. I agree that eventually we're probably going to want to start naming these, with some more interesting names. With the Kepler mission, they've found so many planets that I imagine that it's going to, that it's not like the Kepler mission's one person.
Right.
So maybe people on that mission sometime in the future might get the potential to name things. I don't know. That is a good question.
I'm still going to say you're getting ripped off. So, Cynthia, actually, let's stick with planets, specifically the ones here in our solar system. Am I right in that we've at least done flybys of every planet in the solar system?
Yep, since Pluto is now a dwarf planet, no longer officially a planet, we have done at least flybys of all the planets in our solar system. And interestingly, the New Horizons mission, it's on its way out to Pluto. Back when New Horizons was launched, Pluto was still a planet. And so it takes a long time to get all the way out to Pluto. And so in the intervening years, Pluto's lost its planet status, but it's still a really interesting body. And it's going to have a flyby in just a couple of years now, which will be very exciting.
And have we landed anywhere other than Mars and the Moon?
Yes, we've landed a couple other places. So a lot of people don't know that the Soviet Union back in the early 1970s actually landed on Venus. And not just once, but a whole bunch of times. They had a number of successful landers on the surface of Venus. And these were the Venera missions. And they're really cool missions. It turns out that Mars, while the U.S. has had a lot of success with various NASA missions that have landed on Mars is actually a really hard place to land because it has just enough of an atmosphere that you have to pay attention to it, but not enough to really slow you down very much. So you have to have these crazy systems of parachutes and, airbags like the last couple missions used, and then the sky crane that the current Mars Curiosity rover used. So you have these crazy landing systems on Mars. On Venus, however, the atmosphere is so thick that basically you just need a parachute and you can just kind of float slowly and gently down to the surface. And so using 1970s technology, the Soviet Union tried a whole bunch of times to land on Mars and they were just unsuccessful. But on Venus, they had this system where it was basically just a parachute and it parachuted this capsule, this lander down to the surface. The problem with Venus, of course, is that the surface conditions there are crazy. The pressure, the atmospheric pressure is really, really high. The temperature is hot enough to melt lead at the surface. So basically what you had to build was this giant sort of armored tank of a spacecraft. But of course, if you kind of picture what Soviet architecture or engineering looks like, that's what they excel at, is building these really sturdy, robust systems. So it was a very good sort of Soviet style place to land, actually. So they built these landers. They, a number of them were successful. The first couple actually successfully landed, but the lens cap on the camera it malfunctioned both of the first two. So they landed successfully, but took no pictures. And of course, pictures or it didn't happen, right?
That is awful.
In the 70s too. But the next couple missions, they redesigned the lens cap. And so they did actually manage to get some pictures of the surface. And if you look online, or if you look in my book, I have to plug my book, Space Exploration for Dummies, the original pictures that were released, from these Venera landers they were processed kind of using 1970s technology, and they were kind of reprinted from photocopies, and they just looked really lousy. They were unsatisfactory. Much more recently, using modern computer techniques, a couple of really smart guys have gone back and they managed to dig up the original images from some of these landings off of, decaying 8-track tapes or whatever they were archived on, some horrible decaying medium off in Russia somewhere. They dug up these tapes, they digitized them, and they reanalyzed and reprocessed the images using modern image processing techniques. And these are the only images we have of the surface of Venus because NASA's never landed on Venus. So they reanalyze these images, and they're just gorgeous. It's amazing. You see there's some places where you see these sort of platy pieces of what are obviously broken up lava flows. There's some places that look much more terrestrial, actually. So we've landed on Venus. Then the other place in the solar system, aside again from Mars and the Moon that we've landed on, is a satellite of Saturn called Titan. And this was a really cool landing just a few years ago. The Huygens probe was hitched a ride with the Cassini spacecraft all the way up to Saturn. The Huygens probe was actually built by the European Space Agency. And when it got close enough to Titan, it was ejected, and it went and landed. And again, it used a parachute. Titan has a really, really thick atmosphere. And so you can't really see what's going on the surface from orbit. And so the first flybys by the Voyager 1 spacecraft were really, really unsatisfactory. You just saw this kind of orange, fuzzy-looking ball. You couldn't see the surface at all. And even the Cassini spacecraft has trouble seeing through this really thick, hazy atmosphere all the way down to the surface. So the Huygens probe rode down to the surface on a parachute. And it was really cool because we thought that there could actually be oceans of liquid methane or ethane on the surface of Titan. And so this probe was designed back when it was designed, and even back when it was landing, we didn't know for sure if it was going to hit a liquid or a solid surface. So the engineers who designed this thing had to make it so that it could survive. If it landed in liquid, it would be able to float, and actually had some little probes that could do some sampling and test the surface and figure out what this liquid was made out of. But it also had to be able to survive if it landed on a hard, solid surface. So it turned out that the probe landed on a solid surface. It didn't land in a lake or an ocean. It took some really great, amazing pictures on the way down that shows sort of fluvial channels. So it's really clear that something is flowing on the surface of Titan. And again, it's way too cold for water. So we know that has to be liquid ethane or methane. And while the Huygens probe didn't land in an ocean, we've actually have seen lakes up more in the polar regions of Titan. And so Titan, I think, is going to be a really pretty amazing place to study in the future.
And we have a question from the chat from Tony. And of course, it is the obligatory question.
Have any of the many PCs analyzing SETI data ever found anything interesting or suggestive of extraterrestrial life?
If you could answer that in 30 seconds or less. We all know the answer to that.
Sadly, no. No, we have not.
So sad.
Wah wah.
Thing that is definitive. There have been a couple of interesting, provocative, strange signals, but we have a protocol. So basically, if you detect something weird, first you point your telescope away from it and then back on to see if it's still there. If it is still there, then you try it again with a couple different antennas. And if you're still getting the same signal, then you get on the phone, or I guess these days you get on email or instant messenger these days, and you send messages to 12 of your closest friends at 12 different observatories all around the world to see if they see the same signal. So nothing that we've found so far has even reached that, has survived that level of scrutiny.
You're listening to Skeptically Speaking, and today's episode is Why Should I Care About Space? I have a lovely panel with me. John Zeller, founder of pennyfornasa.org, Cynthia Phillips, planetary geologist with the SETI Institute, John Matson of Scientific American, and Nicole Gugliucci, postdoctoral fellow at CosmoQuest. Nicole, I have not forgotten about you. I first want you to give me your elevator pitch for why radio astronomy is something worth spending money on.
Well, I could give the pitch for all of ground-based astronomy.
Do it.
We've been talking a lot about NASA, but in the U.S. we also have the National Science Foundation, which funds all of the ground-based astronomy efforts in the U.S. And they're suffering from severe budget constraints as well, and are going to have to start closing state-of-the-art telescopes such as the Green Bank Telescope in West Virginia if they can't find other sources of funding. And what these telescopes do, in addition to probing black holes and galaxies and the entire cosmos, I mean, beyond the solar, way beyond the solar system, way beyond the tiny little parts we've been talking about so far. I'm sorry, I'm an extragalactic girl. I think big. But they also employ people in these areas who work to build the telescopes, who work to maintain the telescopes. operators and shop guys and museums and education centers and all these things that are built around these observatories as well are also being threatened by all of these budget constraints. So there's education, there's employment opportunities, and there's the interesting, cool science that gets people interested, gets kids into science, gets them asking questions. One of the first things when you say, sit next to someone on an airplane, they ask you about, what you do for a living. You say, oh, I'm an astronomer. They're like, oh, I have a question about black holes. I feel like it's always about black holes, And so these things interest people and capture their attention. So there are many different reasons why I think, astronomy, not just exploration, but just observing is important.
And that's one of the things I really wanted to ask you about was the education aspect. Mm-hmm. What are the benefits that you see in getting kids that young, that excited about space?
Oh, man. So, yeah, I was on here a while ago talking about Dark Skies, Bright Kids. We go to, this is when I was in Virginia, we would go to classrooms, 3rd through 5th graders and do an after-school astronomy program. And, they've heard of the planets and they've heard of the moon and they've heard of these things, but they don't know as much about them because it's not a huge part of their science curriculum. But they have these amazing questions and they will ask questions about how stuff works. And why isn't Pluto a planet? And how does the sun work? And are we all going to get killed by a comet? And all of these great questions. And it actually encourages them to ask questions, to ask their own questions. And it also encourages them to explore the world around them. We did a lot of hands-on activities. So even though astronomy is something that's up there and, away from us that we can't touch, we did a lot of hands-on experiments, getting them interested in science and getting them to realize that, hey, I can do science too. I can ask these questions. I can understand the universe around me. And so that's been my experience with young kids. And then, just my own experience, I thought, when the Mars Sojourner and Pathfinder lander and rover landed on Mars in the 90s, I just thought this was the coolest thing ever, and I have to study this stuff and do it for a living. So it's inspirational for students who want to go on into science and pursue science as a career, but just anyone who wants to have that knowledge about the everyday world around them and be able to explore the everyday world around them.
Did anyone else have any opinions on that?
My wife's an educator here in New York City, and once a year or sometimes more, I'll go in and talk to her class and just talk about what I do. And these are, over the years, they've been 1st graders and 3rd graders, and they're so fascinated by space, exploration and observation. And they have amazing questions about comets and, why comets have tails and, some of the things Nicole mentioned, it's incredible the amount of innate interest that these kids have. And, having a healthy space program and having a healthy system of telescopes, of course, provides a number of jobs that, career paths for people to pursue, but it also just, encourages students to pursue math and science and, technological careers, gets people interested. I don't think it's an accident that Paul Allen of Microsoft and, Jeff Bezos of Amazon.com and, I'm blanking, but SpaceX,
Elon Musk.
Elon Musk. I know his name, but I couldn't come up with it. But Elon Musk, these are some of the most successful technological entrepreneurs of our time, and they all have private spaceflight companies now. And I don't think it's an accident that interest and sort of inspiration is tied into these people that have gone on to have really important technological careers. So I think, I think the education and inspiration component just can't be overstated.
You're listening to Skeptically Speaking, and we are spending the hour talking about all the reasons that you should care about space. And we'll be right back with more of that after this.
On the next episode of Skeptically Speaking, we're looking at the science of sexual orientation, where debates over nature versus nurture have influenced law, policy, and equal rights. We're joined by neuroscientist and writer Simon LeVay to talk about his research on the topic and his book, Gay, Straight, and the Reason Why, The Science of Sexual Orientation. And astrophysicist Ethan Siegel returns to the show to tell us about a new project using the information aggregation service TRAPIT to improve learning in the classroom. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell. Today we're talking about space with Cynthia Phillips, planetary geologist with the SETI Institute, John Matson of Scientific American, Nicole Gugliucci, postdoctoral fellow at CosmoQuest, and John Zeller, founder of pennyfornasa.org. So we started to touch on this before the break, sort of the less tangible benefits of space, and definitely that sort of social aspect of space is what I was thinking about. I guess the really big example of that was the space race between the US and the Soviet Union in the 50s and 60s. And of course, we ultimately did land people on the moon, but I'm wondering, can't we chalk a lot of that up to nationalism rather than the inspiration of space itself? Or am I just really cynical?
Yeah, no, if you look at the space race, Desiree, it's really, it's like a gladiator arena that's being fought out with champions in space. And so it was a time of, great tensions between the US and the Soviet Union. And we had nukes pointed at each other. We had our finger on the button. And so it's much better that we turned our efforts towards basically a championship. It could have been any, right? And so fortunately for space scientists, this is the arena that was chosen. It was space, right? And so that's really the reason. It was really a very strange geopolitical moment, I would say, and one that we can't really expect to have replicated. It was a time when a much larger percentage of the federal budget was spent on NASA than has ever been spent again. Part of the problem of sort of starting our exploration of the solar system in this very strange way is that it really wasn't scientifically driven at all. Science was really an afterthought. This was a political and technological mission that managed to succeed. It managed to put humans safely on the moon and return them safely to Earth, but by 1969, so before the end of the decade, as John F. Kennedy had originally set out. So it achieved that mission, but part of the problem was that was the only mission. The mission wasn't, let's go and peacefully explore the solar system.
Exactly.
The Russians.
So now you say that you can't replicate that. So why is that?
Well, I think that we don't have a similar geopolitical moment right now. We don't have a reason to spend a huge percentage of our nation's dollars on space exploration. Sure, I really wish they would. I have a great $2.5 billion mission to Europa that I've been trying to get funded for the last 12 years. If we just upped that, took that penny for NASA and had a reasonable NASA-sized budget, then yeah, we could do such amazing things. But I think the reality is that our interests and our efforts as a nation are elsewhere.
What do you guys think about that?
One thing that there are little bubbles of nationalist panic that I see when the subject of the Chinese space program comes up. But the Chinese space program has done some manned launches and some very rudimentary orbital missions, and there's talk that they could put a man on the moon by 2025 or something like that. But that's something that's already been done, and so it's hard to the fact of the matter is that the American space program is so far advanced that even if China managed to land a man on the moon, it would be replicating something that NASA did in the 1960s. So it is a combination of geopolitics, but it's also a combination of, it will be quite a while before, I think, the sort of precedents that NASA has already set are really threatened.
That's true, but on the other hand, we don't even have we no longer have the capability to send humans to the moon. Heck, we don't even have the capability to send astronauts to our own space station that we, spent the majority of time and effort and over the last decades building. I think that we shouldn't discount the fact that, yeah, the Chinese are going to be getting ahead of us. We basically, I think one of our problems is that we spent way too long circling the Earth in the space shuttle rather than investing in any sort of new launch system that could take us beyond lower orbit. And so rather than diverting resources into something that was heading toward the future, we instead kept doing the same thing over and over again. We invented the space station to have a purpose and a place for the space shuttle to go. And fine, there's a lot of good stuff you can do with the space station, but the problem was that while we were supporting the space shuttle, we couldn't make that investment in the next step. And that's what the Chinese are doing, and they're not marching along a path that'll leave them stranded in low Earth orbit. They're coming up with a flexible system with a lot of input from the Russians, who have a great deal of expertise in this, that's going to get them, it could conceivably get them to the moon. And once you have a system that can go to the moon, you can go beyond the moon.
And actually, we have a question on that topic from the chat from Lens Pirate.
Is the defunding and abandonment of the manned space program in the U.S. going to be fatal to the notion of getting humanity off planet in a significant way?
That's really negative sounding. I wouldn't say we've completely abandoned it. Part of it's been privatized, and I'm sure John Zeller could talk about this more, but part of it's been privatized, and part of it is NASA's focusing on building those systems that will hopefully take us beyond low Earth orbit.
Right, yeah, exactly. And that's this question mixed with a little bit of a segue from the last comment is kind of a perfect coalescing of ideas. What I'm getting at is government agencies are not businesses. Government has never been business. Government does not run like a business. What government does really, really well is research. Government, like NASA, will push the boundaries of where we are to go. And like you were mentioning before, one of the big problems has been over the last 30 years is that we haven't innovated in every way that we can. Sure, we have innovated in many ways. The sky crane that we used to lower the most technologically advanced rover ever and landed it safely on Mars was a huge technological advancement. But in other areas like manned spaceflight, again, we've just been circling the space station and with the space shuttle and things like that. So it's worth noting that NASA is at a really, really important time, where we need to be giving it our support. Business will be taking space travel into the future. That does not mean that NASA does not have a key role in that. What this frees NASA up to do is to return to their initial role as the pusher of boundaries and not the holder of just right where we are now all the time. What they should be doing is constantly pushing the envelope and letting businesses take that over. So yes, while we do not have a space shuttle currently, we do now have access to the space station from an American company. And I would say that that is better than having the space shuttle because of the fact that it's going to, over the long run, save us money and allow NASA to push the boundaries of other technologies. And then again, drop that back down towards business and allow us to actually push out into space and discover a lot of new things.
We have a question from the chat from Awamux.
How bipartisan generally is support for NASA in Congress? Would a penny for NASA be politically feasible, if not necessarily economically? Would there be support?
The way that support for NASA works, it's a very interesting sort of bipartisan coalition that's really based on who has big NASA centers in their districts. And that's really what it comes down to. And so you get senators from places like Maryland, Florida, Texas, and California who are really strong proponents of the space program and of NASA. And people from states that don't have big NASA centers or that don't have big aerospace companies, often NASA is way at the bottom of their priority list. And so you do get some sort of strange bedfellows where, for example, there's a very conservative senator from Texas who's, a conservative representative from Texas who's very, very strong supporter of a Europa mission, and that's kind of my pet project. And so it's very strange to be meeting with this senator with whom I don't agree on just about anything, to find that he's sort of the staunchest ally for NASA and for this Europa mission. So it can be kind of interesting.
Yeah, you're right on. It has a lot to do with where the NASA centers are located, and it's almost a breadwinner support in a way. a lot of the members of Congress will support NASA or their programs, not necessarily for the research benefit, but for what it's going to bring back for their districts, which can be positive and negative on both sides. I think one thing that we really need to push towards all of the American people is why NASA benefits everybody, not just someone who has a NASA center right down the street where a huge portion of the local economy happens because of that center. We need to really highlight the aspects of our society that are made possible and that generate a better life for everyone because of what NASA does.
You're tuned in to Skeptically Speaking, and today we're discussing space and why it deserves our attention. My guests are John Matson of Scientific American, Nicole Gugliucci, postdoctoral fellow at CosmoQuest, John Zeller, founder of pennyfornasa.org, and Cynthia Phillips, planetary geologist with the SETI Institute. And we are almost out of time, but before we go, I wanted to look at the question of why we should care about space from a more long-term perspective. Maybe I'll just bring these up in order of basic plausibility, and anyone can feel free to jump in. I think one of the better uses of time looking out into space is the people who are tracking things that might hit us, because I am incapable of not talking about doom in one of these shows. So things like asteroids and comets are what I'm worried about. Now, these things have the potential to be pretty serious threats, right?
Absolutely. I mean, I think if you think about all the ways in which the universe is trying to kill you, and it really is trying to kill you, it's very inhospitable to life in general. The ways in which our planet is in danger is the most is asteroid and comet impact. I'm sure we could talk about gamma ray bursts, sterilizing the oceans and all kinds of crazy things like that, but those aren't very likely. The idea of an asteroid or a comet hitting Earth isn't a matter of if, but it's a matter of when. And I know we hear this and say this a lot. And Bruce Willis is not going to split it in half for us. That's just not a feasible way. So we need to think about ways that we could deflect such an asteroid that's on its way to us. We need to detect it early enough so that we can deflect it. And in the long term, I mean like really long term, we're going to get hit. We're going to get hit by a possibly civilization ending asteroid. And why don't we think about colonization as a way of spreading beyond the Earth?
Well, that was depressing.
I would try to be optimistic. Like, yay, space travel. Let's go explore stuff.
Let's go find them.
Yeah. Anyone
Anyone else want to jump in on that?
I think she covered it very well.
No, good. All right.
Yeah.
Yay, Doom.
So, well, speaking of asteroids, maybe we'll talk about earlier this year, a company called Planetary Resources announced that they were planning to start mining asteroids. So what kind of resources would we be able to find on or in, whatever the proper way to say that would be, objects that we could reach with current technology?
Well, I think I'm not an expert on this stuff, but there's certainly a lot of heavy metals on asteroids and things that fetch a high price back on Earth. I personally am a bit skeptical that we could retrieve those with in a cost-effective way, but if somebody can figure that out, great, more power to them.
I think it's worth noting, too, that a lot of these raw materials, including things like water, fetch a higher price when they're already in space because we don't need to push them up there. And I think that could be a real potential economy of the future, being able to have that kind of stuff available. A kind of pet idea that I always have in my mind is pushing an asteroid that's really, really rich in frozen water out to one of the Lagrangian points, and creating some kind of a stationary fuel depot that's constantly splitting oxygen and hydrogen. And by the nature of the structure of an asteroid, you could build the depot inside of the crevices of the asteroid, and you could roll up with your spaceship and, for lack of a better analogy, just fuel up.
This boy has big plans.
I'm skeptical of the mining as well, but I also want to see asteroids turned into spaceships, so that's even more far-fetched. So you can hollow out. This is an idea that's been around for a while. Is hollowing out the inside of an asteroid and turning it into a multi-generational ship to the stars.
Is that a sort of original Star Trek?
Yeah, I think so.
Well, what about, now we sort of almost touched on this before, but let's come back to it. What about the idea of colonizing space? Is that something, maybe could we do it, but also should we do it?
I think that's the direction we're going in. You know, I think that we're not talking about something that's going to happen in the next 100 years, but eventually we're going to run out of room on this planet. We're going to run out of resources. We're going to run out of space. And I think that we're just going to naturally move outward. You know, we've conquered most of the frontiers here on the Earth. There's a few that are still left. You know, if we continue global warming and the Arctic melts sufficiently, we got a frontier there. There's the bottom of the ocean that we haven't done much with yet. But unless something changes and our population starts going down, I think that we're gonna have economic and just reasons of population that'll push us outward. I think that it'll probably push us into Earth orbit first, but beyond that, yeah, the moon, Mars, asteroids, floating cities. I mean, who knows where people are going to end up? But I think it's going to happen. Not next year, not in 100 years, but the next 1,000 years, yeah.
And also, I mean, just driven, just if you look at human history and the way that we have explored, what's over that next hill, or, what's at the end of the ocean, is the Earth flat or round? We just keep looking and exploring further outward. So whether for practical reasons or just for exploration and curiosity, I mean, whether we're actually sending probes or sending people or just looking out into the solar system, into the galaxy, into other galaxies beyond, it seems to be just following the natural trend of things.
I totally agree with that. If you look back, we started in caves, we left caves, we started to build houses, we left our houses, we started to move away from continents, build ships. It seems like a natural progression to me as well.
Yeah, I would love to be a science officer on the bridge of the Enterprise. That's just my goal.
I love it.
Well, since we are almost completely out of time, if you could leave the audience with anything that we haven't covered, why should they care about space?
Because it's there.
Oh, that's an interesting one. Like Everest.
That's I think the greatest justification for space exploration that there is.
Yeah, I think even if you don't agree with spending money on exploring space, I think everyone cares about space. I don't know of one person who has never looked up at the stars and thought about what's up there. It's something that everyone looks at, everyone thinks about, everyone wonders about. It's just a natural part of being human.
Yeah, it's the human race reaching out and thinking about something far vaster than this planet that we live on. That is something that's philosophically and spiritually important to us.
Right, absolutely. And we've always been explorers. And from an even different point, not just doing it because we've always done it, but we're here, we're on this planet, we're in this universe. We should go out and explore it and try to understand it the best that we can.
Well, I'm convinced.
Yay!
Go space.
Mission accomplished.
Thanks to all of you for being here.
Thank you, Des.
Thanks.
And you'll find links to Nicole Gugliucci, John Zeller, Cynthia Phillips, and John Matson on our website at skepticallyspeaking.com. You can also find links to Twitter, Facebook, and Google+, which will keep you posted about the upcoming shows, and of course to iTunes, where you can subscribe, listen to past episodes, or leave a review. And my humble apologies to all of you that didn't get your questions answered today. Maybe if the guests wouldn't mind, I can post some of those on the website, and someone might want to answer them.
Sure.
Yeah.
Absolutely.
Lovely. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, break the spell of Pavlov's bells. Cause we're skeptically speaking, on mind reading tarot cards and witches, psychics, and their spoon-bending mind tricks. All the humbug, flim-flam, frauds and shams, the charlatan who I don't think you understand. It's the hocus pocus, out of focus locus, eroding the brain, making gains on the hopeless. Let the crystal ball fall, smash on the floor, leave the pieces alone, we don't need them anymore. Just a microscope, telescope, magnifier, reading in between the lines of these lies. Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, metaphorically that is, cause we're skeptically speaking.
Skeptically Speaking is produced and distributed by Suburban Panic Media. Our studio assistants are Helen Cavillion and Chelsea Butler. Ryan Bromsgrove is our studio technician. The show is edited by K.O. Myers. Our theme song was written and recorded by A.OK. And I'm your host, Desiree Schell.